we're tackling the problem linked list cycle, and we're going to try and solve this with minimum complexities of on time and o1 space. We're given the head of a linked list and need to determine if that linked list contains a cycle. A cycle in a linked list occurs when a node in the list can be reached again by continually following the next pointer. The linked list does not have a parameter indicating the position of the node where the tail's next pointer is connected, so we can't just use that. Our task is to return true if there is a cycle in the linked list and false otherwise. Your four potential options for the optimal solution are A. Floyd's tortoise and hare, B. Floyd's hash table, C. Traversal of the linked list plus visited array, or D. Reverse the linked list. I'm going to pause for a couple of seconds while you make your choice. So, for those of you who are able to get this, congratulations. And for those of you who just want to see some code, the answer is A. Floyd's tortoise and hare. Now, our brute force approach would simply involve using some kind of set. We could add all of the nodes to a set, and if we encounter the same node twice, we know we have a cycle. However, this has on space complexity, and we can obviously do better than that. Let's take a look at how. So this solution uses Floyd's tortoise and hare algorithm to detect cycles in a linked list. We utilize two pointers, tortoise and hare, which are both initially set to the head of our linked list. The tortoise moves one step at a time, while the hare moves 2 steps, as you can see here. If there is a cycle in the linked list, the hare will eventually catch up to the tortoise. And if that happens, then we'll be returning false. If that happens, we're returning true, because we have found a cycle. Excuse me. If the hare reaches the end of the list, that is, it becomes null pointer, then we can conclude that there is no cycle and safely return false. Let's go through this one more time with no more slip-ups from me about whether this has cycle or hasn't cycle. So, line by line, the function definition has cycle. It takes a pointer to the head of the linked list, and we're returning a boolean indicating whether the list has a cycle or not. True if it does. We then initialize 2 pointers here to the head of the linked list, named tortoise and hare, just like Floyd would have wanted. Our loop, which is a while loop, continues until the hare pointer reaches the end of the list, that is, becomes null pointer, or goes beyond the end, where hare's next is null pointer. Then after that, we're moving the tortoise pointer 1 step forward and the hare pointer 2 steps forward each time. If tortoise and hare are the same node, essentially here we're checking if the tortoise and hare pointers meet, and if they do, it means we have a cycle, so we return true. If our loop completes without finding a cycle, we're going to return false. So I hope that that's clear. It's quite a simple problem with quite a memorable solution in my opinion. If you need further help with linked list problems, check out the linked list section in the Udemy course in the description to this YouTube video. Just to complete this video, we'll remind ourselves one more time of the correct answer for this: Floyd's tortoise and hare approach. Why? Well, there's a written explanation I'm not going to read to you. If you need further help with specific programming languages, you can check out the code in C++, Python, or Java. So, that concludes this one. I believe that the next problem in this series is going to be linked list cycle 2, which is a slight variation and possibly a good follow-up in a real interview. Thank you very much for watching.